Hello everyone, this is Dikshita Kakarla. Today we are seeing one of the topic in IoT, Raspberry Pi. Its introduction, hardware layout, operating system, configuration to programming about the wireless monitoring temperature system. So, introduction to Raspberry Pi. The Raspberry Pi is a series of credit card sized single board computers developed in the United Kingdom by the Pi Foundation to promote the teaching of basic computer science in the schools and developing countries. Several generations of Raspberry Pi have been released. The first generation, that is, the Raspberry Pi 1 Model B, was released in February 2012, followed by a simple and inexpensive Model A. In 2014, the Foundation released a board with an improved design of Raspberry 1 Model B+. Next, improved A+ and B+ models were released a year later. Now let's see about the Raspberry operation systems. Various operation systems can be installed on Raspberry through SD cards. Most use micro SD slot located on the bottom of the board. The Raspberry Pi primarily uses Raspbian, a, a Debian-based Linux operating system. Operating system not Linux-based, RISC OS Pi, FreeBSD, NetBSD, Plan9 Formlabs, and Inferno. So operating systems which are Linux-based are Xbian, using the open source Digital Media Center, OpenSUSE, Raspberry Pi Fedora Remix, Gentoo Linux, Diet Pi, Kali Linux, Arc OS, NAD SDK, Kano OS. So now let's see the configuration to programming Raspberry Pi. Raspberry Pi runs Linux and supports Python out of the box. Hence, for you, hence, you can run any Python program that runs on a normal computer. However, it is the general purpose input and output capability provided by the GPIO pins on the Raspberry Pi that makes it useful device for IoT. Simple programs on Raspberry Pi are print hello world. Now, now let's see about wireless monitoring temperature system. A wireless temperature monitoring system in IoT typically involves sensors that collect the temperature data, transmit it wirelessly to the central hub or server, and then process and analyze the data for various applications. So here's a basic overview of how such systems might work. So we have sensor nodes, wireless communication, central hub or gateway, cloud, etc. So let's see one by one. Sensor nodes. These are the devices equipped with the temperature sensors, such as thermistors or thermocouples, that are placed in the environment to monitor the temperature. These sensors can range from simple, low-cost sensors to more sophisticated ones, depending on the requirements of the application. Wireless communication. The sensor nodes communicate wirelessly with a central hub or a gateway in between. Common wireless communication protocols that are used in the IoT applications are like Wi-Fi, wireless fidelity, Bluetooth, Zigbee, LoRa, and cellular, that is 2G, 3G, 4G, as well as 5G. Central hub gate, Central hub or gateway. This device acts as a bridge between the sensor nodes and the internet. It receives the temperature data from the sensor nodes and may perform some initial processing or aggregation before transmitting the data to the cloud or the local server. Cloud or server. The temperature data collected by the sensor nodes is transmitted to the cloud-based platforms or the server for the storage, processing, and analysis. Cloud platforms such as Amazon Web Services IoT, Azure IoT, or Google Cloud IoT provides various services for managing the IoT of data. Next comes data processing and the analysis. So once the temperature data is stored in the cloud or server, it can be processed and analyzed for the various purposes. The various purposes can be like real-time monitoring, historical trend analysis, or like for predictive maintenance, and also for anomaly detection. So machine learning algorithms can be applied to the data to extract the insights and make the meaningful predictions out of it. And next is like user interface. So a user interface such as web or mobile application that allows the user to visualize the temperature data, set the thresholds or alarms, and receive the notifications in case of abnormal temperature conditions. So this was all about the Raspberry Pi hardware layout, what is the operating system and the configuration for programming, and about the wireless monitoring temperature system. Thank you.